It's your friendly math tutor, Miss C, here to convert general form of a quadratic function to vertex form by completing the square. All right, we have our equation written in general form here. We need to get it written in vertex form. So let's go ahead and get started. The first thing I'm going to notice, because this is really important when we're dealing with vertex form, is that I'm going to look at my a value. And in this case, my a value is -1. Because it is not +1, it means we're going to have to do a little bit of extra work, but have no fear. I've got you covered. Let's go through this step by step. Step 1, we are going to divide our equation into two sides, the left side and the right side. I always do this so that there's no confusion about doing something to one side and then doing it to the other. It's kind of the principle of mathematics. Okay, our first step is going to be getting all the x's on one side. And there are two x terms. We've got the x squared term and the x term, which means that we need to move our constant, which is -70, to the other side of the equation. To move that, I'm just going to do the inverse operation of subtraction, right? I'm trying to get rid of it, so I'm making it 0. What I do to one side, I do to the other. So I'm adding 70 to both sides. And I'm going to rewrite this. So I have y plus 70 equals -x² minus 18x. Our next step is to deal with this -x². So our a value is -1. So we would do this process anytime we have an a value that's not 1. And what we want to do is we want to factor out the a. And in this case, it's a negative. So some people just write the negative when they do this. Some people write a -1. I'm going to go ahead and write a -1 just to be very clear with what I'm doing. But if I were doing this personally in my own math work, I just write a negative sign. So whatever you want to do is fine. And now I'm going to factor that out. And factoring out is another way of saying I'm dividing the -1 out of each term. Essentially, that means here I have -x² divided by -1. When I do that, I just get x². I'm going to do the same thing to -18x divided by -1, which gives me positive 18x. Okay, very important. You have to do that to both terms. And now we are going to complete the square. It's called completing the square because when we do it, we are making a perfect square. So the way that we do that is we look at our b term, and the b term is always attached to the x. So in this case, it's positive 18. And what we want to do there is we want to cut it in half or divide it by 2. So I'm going to say 18 divided by 2 is 9. That's the first step in completing the square. And now we actually have to square it. So now step 2 is we square 9. And when we do that, we get 81. So I'm adding 81 here. Now, this is where we have to be careful. So if you've watched my other completing the square videos, or you know how to complete the square when you don't have an a value, it looks like I just added 81 to the right side. And what I do to one side, I do to the other. But whoa, slow down. We didn't actually add 81, and here is why. This -1 is being distributed to every single term in this trinomial that we just created. And if we want to do a quick check, x² times -1 is -x². That means we factored -1 out correctly. -1 times 18x is -18x, factored it out. And this is now the value that we have added to the right side is -1 times 81. So we've actually taken 81 away from this right side. And if we've taken 81 away from the right side, we have to take 81 away from the left side. All right, so I'm going to go ahead and clean this up and simplify a little bit. I'm going to combine my like terms on the left side. So that gives me y minus 11 here, right? -81 plus 70 is -11. And now I'm going to replace this -1 with the negative sign. And now I'm going to write this as a binomial squared. So as a reminder, this value is always the x value. And then I always look at my very new perfect completed square, and I take the square root of that. So the square root of 81 is 9, and that goes here. The sign that goes inside or in between these two values is always the sign that's in front of my b term, which in this case is a positive. Okay, because remember, if I were to distribute this, I would need this term to add to negative or to positive 18x. So this has to be positive. All right, we're almost done. Now we just need to get everything but y shifted over to the right side of the equation, because remember, I'm trying to make it here. So I'm going to add 11 to both sides because that gets me y by itself, because y plus 0 is y. So y equals negative times the quantity x plus 9 squared plus 11. All right, great news. We are in vertex form. We can now identify the vertex, which is really the reason that we get this into vertex form. So to find the vertex, I am looking for the x term first. And what I look at is this binomial right here. And I want to make that binomial equal to 0. When I do that, what value does x have to take on? So if x is negative 9 plus 9 is 0. 0 squared is 0. 0 times the negative is 0. And I'm left with the y value of 11. So that's how I find the vertex. So my vertex is negative 9, 11. Now, this graph is interesting because a is negative 1, right? Remember this? This reflects our graph over the x-axis, which means this vertex is actually a maximum value. It means that my parabola, if I were going to draw it, looks like an upside down U. And this negative 911 is the highest point or the maximum point on the graph. So that's it. We have converted general form to vertex form. By completing the square, we identified the vertex. We determined that our vertex represented the maximum or the highest value on our graph. Well done. All right, thanks for joining me. Make sure to subscribe for more math videos. Till next time, remember, you've got this.